Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In this lesson, we're going to talk about some of the ways that we can write safer code in the D programming language. And that's with the function attributes like @safe, @trusted, and @system. If you've been following along this series, you've seen some of this arise with @safe and @system, for instance, when talking about some of the memory safety issues that D tries to help us with. And these are really, really important things these days to understand memory safety and just some ways that we can write safer code. Now that said though, every once in a while we do need to dive down into the lower level, which is a nice thing that D does allow us to do. But we can do it a little bit more safely by understanding these attributes. So with that said, let's go ahead and dive in and understand exactly how this works. Now from the D programming webpage, what I'd like you to do, if you want to follow along, is just go here to the documentation, library reference, and let me make this a little bit bigger so you can see. We'll go to the core, then down to standard C library, and again, the standard lib. And we're going to be looking at functions like malloc, for instance, and free, which are, not what are considered safe functions according to the D programming language, as well as maybe just developers everywhere. They're really low-level functions where you can get things like segmentation faults and all sorts of different errors. But really, they're just a nice example for what I want to talk about when it means to write sort of safe code. So with that said, let's go ahead and import this library here so that we have our memory allocation functions. And again, I think this is just as a good example. And what I'm going to go ahead and do here in a moment, and just to start, is write a function called memory allocation. And for now, I'm just going to leave it blank. Okay, so I'll leave it blank here. We'll come back to malloc in a moment, but what I want to talk about is these attributes in our functions. So what does that mean? Well, if I run this code, again, it runs fine. And the reason it runs fine is D follows some rules about what functions can call other functions. So for instance, if I call memory allocation within main, this function that we just wrote, that is fine. The default attribute on every function, whether you write it or not, is @system. Okay. So let's just go ahead and put it in here to go ahead and see that it works, and this works fine. So behind the scenes, our functions are labeled @system here, and those functions can call other @system functions, okay? And that's just sort of a rule, and it sort of follows this transitive property here, meaning that a system function that's regarded or annotated at this level of @system can call another, @system function. And that's just sort of how the chain works here. Okay, so that's the idea. Now let's go ahead and shake things up a little bit with this other attribute. Let's go ahead, and we've explored this a little bit when talking about pointers and some of the ways to avoid errors, and add @safe here. Okay, so go ahead and compile this. I'll try to run, and immediately I get an error from the D compiler here saying @safe function D main cannot call @system function. Okay, so here's the sort of rule. We have an @safe function, and it must call, well, let me go ahead and illustrate to you, another @safe function. And again, this is continuous along the chain here. Okay, so what if I go ahead and make this an @safe function? Then I can go ahead and compile. Voila, it works fine. And that sort of makes sense. You would sort of want developers to annotate their functions as safe here, okay? And if you have the actual interface, and we'll talk about what it means to maybe build libraries later on in the series, and you know that these functions are safe, you have some guarantee about some third-party library, and that's very nice. You know that it maybe won't do things that are dangerous regarding memory safety or the rules associated with @safe. But what happens when, in this actual memory allocation function, I sort of want to be able to do some of these lower level things. So in our previous lesson, we talked about allocating memory here. So let's go ahead and use that malloc function. And let's go ahead and we'll just write it out here. Malloc, the size of however big an integer is, and 5 of them. Well, as soon as I introduce this function here, which again, by default, I said is @system within an @safe function, if I try to run this, it is going to give me the error here. It's going to say @safe function main.memory allocation cannot call system function, core.standardc standardlib.malloc here. Okay, because it's calling into this function here. So how do we get around this? What can we do as developers? Well, depending on the language that you use, there's usually rules for getting around things here. So what I can actually do by using these annotations here is I can come into my code and say, I've looked at this very carefully. I've remembered when I allocate memory, I'm also going to free that memory. I'm still going to run it and say, well, this is still a system function and I can't trust it. But, I've been a very good developer. I've code reviewed it, maybe had peers look at it, run different testing tools on it. My unit tests are all passing. So this function, because sometimes you just have to manually allocate memory or whatever the task is, I'm going to say it's trusted. Okay, I trust this code. And now what I can do is actually call this function here. So trusted serves as the bridge here. Okay, so what I can do here is I can call at save code, and I'll just go ahead and label it here. Can call into at trusted code, which can then call into at system code. Okay. And then, we can proceed forward. So trusted is the bridge. That is that tool that says we've sort of verified it. It's sort of saying, well, all of the system code, we're essentially going to mark that as trusted or safe in the compiler's eyes. Again, it doesn't mean that you won't have bugs, but it means that you're sort of turning off the rule set, okay? Now, chances are when you're looking at a code base and you have at trusted, if there are weird memory errors, that might direct you into the right direction. That's sort of the purpose of having these annotations. Now, I can argue whether at safe should be the default or not, and I think there could be some ways to do that, or you could just manually, add safe on all your functions, or literally when you add at safe on main, that means every function that it calls needs to be at safe. So by definition, you're sort of safe in that way. So that's just something that you can follow there in that way. So I want to go ahead and just point you to an article that is interesting or has some other tips here. And it's on the D articles section, or you can search for it, or go ahead and scroll up to the title. How to write at trusted code in D has some other tips here. And there's a really neat tip from Stephen, who wrote this article here. That'll go ahead down here, is on occasion you might want to write, safe versions of functions, which you can do in lambdas. So he calls them, at trusted escapes. So I'll just go ahead and point to that. Later on in this series, I'll talk about lambdas, and we will, think about adding some of these annotations. I just thought it was a nice trick. Okay, so folks, hopefully that helps you understand a little bit of the sort of memory safety here with the D language, or I should just in general say this, this general safety that the language provides. It's nice that there's a mechanism in here, and it's a relatively simple thing to implement. Even if you have a code base that's relatively mature, you can start looking at some of these things like at safe or other attributes to put on your functions. Okay, we'll learn about some other ones like no GC and so on later on in this series as we progress. So make sure that you subscribe or otherwise follow along so that you can catch those updates. And last but not least, I'll go ahead and just mention this. I've been mentioning this more, that these lessons are available on my website if you want to watch them sequentially and track your progress. That's the advantage of signing up there. But otherwise, thank you for your support as always. Thanks for your time and attention in looking at this lesson, this new technique here, and hopefully it will make your deprogramming more safe, more enjoyable, and help you just spend more time writing and implementing code rather than fixing pesky bugs. All right, folks, as always, thank you for your time and attention, and I'll look forward to seeing you in the next video.